Good evening, everybody. I welcome you all for the 28th lecture of webinar series of Archaeological Sciences Center, IIT Gandhinagar. As all of you might be knowing, we have been hosting this monthly webinar since October 2020, and we have successfully hosted several prominent speakers. And today we have with us Dr. Randall Law, who is a well-known expert on provenance studies. He has done a lot of fieldwork both in Pakistan, India, Oman, and visited several raw material sources personally. And his PhD thesis is one of the prominent works in the archaeology of Harappan civilization, and lot of us are also collaborating with him on various aspects. So I will now request Unka to introduce the speaker, followed by Randall. He will be delivering the talk, and later on we'll have the Q&A session with him. And all of you are requested to post your questions in the Q&A chat box. Unka?
Good evening, everyone. So for today's talk, Professor Randall Law will be delivering the lecture on characterization and geologic provenance studies of stone and metal artifacts, case studies from across South Asia. Professor Randall Law is an archaeologist specializing in geologic provenance analysis of stone and metal artifacts. He received his PhD in 2008 from the University of Wisconsin-Madison under the direction of Professor Mark Canoyer, and his research focuses on reconstructing the trade and communication networks of the Indus civilization of South Asia. He has participated in excavations and has conducted extensive field studies in India, Pakistan, and Oman. So we would like to thank you for your valuable time, sir. We will now begin the talk.
Thank you, Unka. I'd like to begin by thanking Dr. Prabhakar and Dr. Danilo and the faculty at IIT Gandhinagar for asking me to give this talk. Prabhakar and I are old friends, and he well knows that I can talk on this subject for hours and hours, all day if necessary. But given that our time is limited, and I will get directly to the presentation. I want to highlight, during this presentation, I want to highlight really three main areas. And the first is this. Obviously, I'm going to show multiple case studies of the geologic provenience analysis of stone and metal artifacts from Pakistan, India, Oman, and various other places. I'll do that throughout this talk, but I really want to begin by emphasizing the processes and the background studies that I needed to undertake in order to make such studies possible. And finally, throughout this talk, you'll see that I will highlight the various archaeologists and geologists who have been my collaborators over the years. And this is very important because although it is my name alone on this presentation and many of the publications, what I'm presenting to you, what I've done really over the last almost 25 years is not by any stretch of the imagination my own work at all. This is very much a collaboration. So let's begin. Most of my primary focus is the Indus civilization, and given I don't really need to give you a great deal of background into that. But my main research, what fascinated me about the Indus and what drew me into this research problem in the beginning was the vast area across which it was spread, and how this, in a lot of regards, massive civilization was held together, and how communication and trade took place across this huge area and to areas beyond. We have evidence that the Indus was interacting with not only across northwestern South Asia, but as far away as the Akkadian Empire of Mesopotamia. And this eventually drew my interest into earlier and later periods, some of which I'll touch on today. Now, I did most of my I did my graduate studies at the University of Wisconsin-Madison, and I came here particularly to work with a man that you all, at least you know his name, and many of you probably met him, Professor Mark Knoyer. And it's he that brought me to South Asia for the first time and introduced me into the world of Indus and Harappan and South Asian studies. He took me in the year 2000 to the site of Harappa, and I did excavations with the Harappa Archaeological Research Project, directed by Professor Knoyer and co-directed by Dr. Richard Meadow from Harvard University. Now, I won't spend a lot of time explaining about Harappa. Everyone knows it very well, but I will say that it has, and I'm certainly not disparaging any other excavations in South Asia, but in South Asia, this has the most detailed chronological sequence, and they've been excavating there at this most recent project. They recently came up on their 100th anniversary, but this most recent project has been excavating there since 1986, and they have a detailed chronology and a well understood material culture sequence throughout the entire stratigraphy. And there have been many research projects there, and these are focused on ceramics and shell and fauna. And speaking of starting with ceramics, it was George Dales working in conjunction with Professor Knoyer that literally wrote the book on ceramics with their work, not only at Harappa but Mohenjo-Daro, and we have a great understanding of the Harappa work, ceramics through their research. Professor Knoyer himself, he did his PhD dissertation on shell and starting to look at long-distance trade networks across this region. One of Professor Knoyer's students, Dr. Bill Belcher, also looked at fish remains, faunal remains of fish, and through that looked at trade and, in some cases, long-distance trade networks of fish products. Brad Chase, who I was talking with Prabhakar and Sharada earlier, has done a isotopic study of faunal remains in Gujarat, and he will eventually do some at Harappa as well. And but it came to me to largely study the stone and metal artifacts from Harappa. And why did I choose to study this? Well, obviously, stone and metal artifacts are among the best preserved and most immutable and changeable artifacts you can find in an archaeological record. They're highly variable, particularly at a major urban center like Harappa, and they're essential to the development and functioning of early urban societies. Why are these essential? Well, obviously, I mean, things like semi-precious rocks and minerals, Vesuvianite, carnelian, and various other gold, silver. These are materials with which not only are they cultural signals, but they're wealth items, and by amassing these, great wealth can be not only displayed but transferred. Now, just as important, arguably, maybe even more important in my mind, are the utilitarian stones. Stones you need for things that you do every day. Grinding stones, chert tools, various things you need to work to make day-to-day life work in an urban society. Now, fortunately for me, by the time I got to Harappa in 2000, they'd been excavating for a number of years already. And throughout the sequence, they already had a large assemblage of stone and metal artifacts, and they were highly, highly varied. And Harappa is amazing. And so many of the sites that I've what I'm about to show you is true of Rakhigarhi and Dholavira, and even small sites like Chanandaro in Sindh or Shikarpur in Gujarat. You can walk across these sites and just do a simple surface survey, and you can pick up by the handfuls the evidence right there on the surface. Here's from Harappa, Vesuvianite, chert, copper. This is just a simple surface survey. Minutes, you've got a handful of this stuff. There's no lack of this material. Now, I'm not the first to research it. There have been researchers, archaeologists, material scientists, chemists like KBM Sanula, Ernest Mackay, Horace Beck, A.L. Coulson. They have been looking at this material for 100 years. So I'm really, the work that I will be presenting today, I'm really standing on the shoulders of giants. They already knew a great deal about this stuff from sites like Harappa and Mohenjo-Daro. And there was work subsequent to that. D.P. Agrawal looking at ancient metal technology, and others have worked on these materials over the years. And when I came to this, a great deal was known already. And the aspects using this evidence and other types of evidence, faunal, ceramics, and various other things. They've looked at trade both within and researchers like D.K. Chakrabarty, Shireen Ratnagar have looked at trade and long distance communication across South Asia and well beyond, excuse me, for many years. And one of my, for me, one of the most influential books was Nayajot Lahiri's The Archaeology of Indian Trade Routes up to 200 BC. And this book, this is actually, I'm showing you, is my personal copy. And I have absolutely worn this out. It's in pieces. I've taken this across the world, back and forth many times. It's falling apart. But I have pored over every word in this. It's a magnificent book. And Professor Lahiri said one very important thing in this. She wrote that a qualitative leap in studies of trade in ancient India can only happen if detailed and large-scale scientific studies on different kinds of artifacts and their raw material sources are undertaken. And D.K. Chakrabarty, actually, in his book, said something very similar to this. And I took these to heart. I took them almost as a challenge that I would, for my research, I would focus on doing just what she is suggesting here. And so, from about 2000 to 2004, I focused mostly on Harappan stone and metal artifact assemblage, studying it, documenting it, looking at each and every artifact of the hundreds of thousands, each and every stone and metal artifact of the hundreds and thousands that there are at the site and cataloging them. And I broke it down here into major varieties. At the site of Harappa, this is just Harappa, steatite and chert are by far the two most abundant materials. But there is these others throughout the sequence that, although they may appear to be there in minor amounts, they're by no means minor varieties. And locating where they originated from can help us tie the long distance trade and communication networks from this one site in the middle of the Punjab plain to the raw material sources. Now, there are really four main steps for successfully sourcing stone and metal artifacts. And the first one is, first and foremost, you have to locate the natural occurrences of the rock and mineral type being investigated. When you've done that, you need to collect a representative range of samples from each potential source area. You need to demonstrate some type of chemical or isotopic or mineralogical variability between the different sources. You have to demonstrate that that is greater than the variability within the individual sources. And finally, you have to establish a set of analytical parameters that will allow sources to be differentiated from one another and the artifacts to be assigned to them with a high degree of confidence. Going back to the first one, the first point, A, locating potential sources. This is me some years ago poring over the geologic maps of Baluchistan. And the great thing about working in this part of the world is that the geology is, particularly since it's across such a broad area, is highly diverse. To the north and west of Harappa, you have younger Eocene rock, and to the south and southeast, you have older Cambrian, Precambrian formations. And the minerals that occur through that occur throughout these regions there are many types that of the same types that occur in both regions, but because of the ages and the various geologies of the rocks, you potentially are able to differentiate them. So the next thing you needed to do, once you understood the geology broadly, is collect a representative range of samples. And again, this is me collecting samples. This is probably 23 years ago, nearly. And this was for me and for anybody is the most almost the most enjoyable part of this whole thing is because you get to move around. I collected samples through Sindh and Baluchistan and North Brazil, all the areas up along the Afghan border, into northern Pakistan, through the Salt Range, over into India and Jammu and Kashmir and Himachal, down into Rajasthan, into Gujarat, and even across the Arabian Sea to samples in Oman, collecting samples in Oman, an area with which Indus civilization peoples were known to have interacted with. And and this is an incomplete map, but I managed to collect samples, sample locations in each and every major area surrounding the Indus Valley Basin. And this is by no means comprehensive. There are areas I would still love to get back to, samples I would like to collect, but at least I have samples from all areas. Now, while doing this, it was, I say it was a lot of fun, and it was. I had friends that accompanied me. I met interesting people, and some of these people helped me collect in some of the more difficult areas, helped me collect some of the materials that I was looking for. But I want to specifically thank some of the geologists and archaeologists. The late Saeed Dr. Hamidullah of the Center of Excellence in Geology was instrumental in getting me permissions to go to some of these more troubled areas. Saeed Bakri at the Pakistan Natural History Museum, I conducted probably the most intense month of field work in Sindh in the Salt Range, Pakistan with him. In India, Professor Manoj Pandit of University of Rajasthan, I did a copper sourcing project with him. And Ashok Grover, he is an exploration geologist of the Geological Survey of India, also from Jaipur, Rajasthan. And there is no man on earth that knows more about the mines of Rajasthan than this one here. Now, it wasn't just the geologists that I was working with to collect these materials. Professor Knoyer taught me very early on, this is Professor Knoyer, we're in Karachi, wherever I go, always visit the Joris, the traditional stone sellers. And I would go every place I went, any time I would see these guys, they would have materials in their small cases from all over the region. And they could tell you surprisingly a great deal. I visited these guys in Jaipur, in Agra, in Peshawar, in Karachi again, in Islamabad, and I would go through their cases and they would explain to me not only what the materials were, where they were from, the local names. So when I went out into the field, I knew what to look for and I knew the local names for things. And in this way, people could help me locate these specific sources. I did not just talk to the stone sellers, I talked to the craftspeople that still today work on the stones. This is from a steatite carver from Wasbela in Baluchistan. This is an agate worker from Cambay in Gujarat itself. And so I could go to these people as well and say, where are you getting these materials from? And they could usually point me in the right direction to locate the actual raw materials in the surface, in the landscape of the region. I also visit the Pansaris, the traditional herbal and medicinal specialists, because in there, just like the Joys, in their cases, they had they used a lot of stone, a lot of different types of stone in their medicinal remedies. And it got me thinking that a lot of the stuff that we were seeing at Harappa wasn't there necessarily to make beads or things that they were using for day-to-day activities. They may be, a lot of this stuff may have been medicinal, particularly some of the lesser miscellaneous varieties of stone. Anyway, I traveled and traveled, and I talked to people, and I found places on the landscape, and I came back with literally truckloads of material. This is a photograph from the Rory Hills of Sindh, and we're bringing home just huge nodules of Rory chert, which was a type of chert that Harappan peoples were using a lot in those days. So now that I've got all the material together, you have to demonstrate the chemical or isotopic or mineralogical variability between different geologic sources. You have to demonstrate that that is greater than the variability within the sources. So you need to conduct types of analysis. Now, some of this analysis involved basic mineralogical testing. Some was a little bit more sophisticated, say X-ray diffraction analysis. Some of this was simply characterization or with VPSEM, EDS. Some of these were very technical, instrumental neutron activation analysis, inductively coupled mass spectrometry. But some of them were more simple. Some of them were just systematic comparative studies, just looking at what you have with a set of mineralogical criteria was enough to differentiate things. And so in the end, I looked at dozens, and this is a small list here, of types of material that we found in Harappa. I looked at grinding stone, chert, steatite, agate, carnelian, Vesuvianite grosser, limestone, basalt, alabaster, lapis, and types of metals, lead, silver, copper. I haven't done a study on gold yet, but that's on the list. As you can imagine, all of this running around and this analysis was very expensive, and I have many organizations to thank for this, which I will not go through here, but the support of these institutions was invaluable. So with that, with the stone collected and analyzed, you have to establish a set of parameters that will allow you to differentiate one source from another and assign your artifacts to those sources with a high degree of confidence. There are many ways to do this. Some of these are, again, involve statistical analysis, which I won't go into the details here. Some of these in the bottom are simply, characterization studies and mineralogical studies, which one I'll show you here in the bottom in just a sec. But there are many different ways to establish these parameters. And we can talk about these maybe in the question and answer sessions if you have any questions about those. Now, with all this information, when you plot the different available sources across this huge landscape, with this information in hand, you can recreate the acquisition networks, the raw material acquisition networks, in great detail for different periods of time. And you can see as the Indus civilization grew, the raw material sources that they were tapping and that they were exploiting changed through time for various regions. Now, how do you explain this? Well, I can talk to you specifically about this one site, but about Harappa itself. But actually, that was primarily the focus of my dissertation research. I was fortunate in this time that I got to begin to work not just at Harappa, but other sites. I eventually studied, thanks to Amarinder Nath, I got to study I was given permission to study artifacts from Rakhigarh. And full stop here, with the exception of Professor Knoyer, no one has helped me and been so kind to me in this field as Dr. R.S. Bisht. he is as much as Canoyer, and in many ways, and in different ways, has really made my work possible. His example and encouragement has been an inspiration to me, and his generosity in allowing me to look at the materials from Dolavira. And of course, I've made some great friends who have helped me. Dr. Tejas Garge, Dean Prabhakar, he's invited me for this talk. The late S.P. Gupta was a wonderful inspiration and opened many doors for me. The faculty at MS University Baroda, Ajit Prasad, K.K. Bhan, Dr. Krishnan, all three of them and the other faculty there have been more than generous and allowing me to look at their materials. Professor Dr. Shinde, who you all know, I've known him for many years. He invited me down to Deccan College, Pune, to look at the various collections from not only Harappan sites, but sites bordering the Harappan area in Rajasthan and Maharashtra and various other places to look and study at that material as well. And in Pakistan, more recently, Dr. Abdul Samad, who's the director of archaeology and museums in Khyber Pakhtunkhwa, and Dr. Shakarullah Hazara in University, who have encouraged me and continued to open up their material collections to me. So much of this can be found, some of what I'm going to be presenting today can be found in the updated version of what essentially was my dissertation, which was published in India in 2011. This is freely available for download, so if anybody wishes to get a copy of this, it's freely available online. Just let me know and I'll make sure you get the correct link. So now, let me at this point go into some case studies. And I want to begin with grinding stone. Now, I wanted to begin with this because as I'll explain why I think grinding stones are important, but this is the type of material that you can bring to bear if you wish some very powerful and expensive instrumentation to differentiate sources of grinding stone. But if you're lucky and you are working at a site in an area where surrounding it, the grinding stone is highly variable, and you may be, in this case, I was able to differentiate grinding stone just using simple mineralogical identification. Now, why are grinding stones important? Well, grinding stones are essential for the preparation of staple cereals and other foods. And we have, not only are they still used in certain areas today, we find them at Harappa, we find terracotta figures that are obviously preparing grains using grinding stones. And they're not just for preparing foods. I mean, you use different types of large stones for, leather working and bead grinding and grinding quartz to make faience and various other things. So, but they're big. It's not like beads. These are big. By weight, they are the most abundant stones at most archaeological sites that you find these. And at a place like Harappa, there were a lot of them, and they were highly varied. I mean, there were a whole lot of them. There are thousands of these, not tens of thousands, but thousands of these. Now, this is a slightly old slide, but at Harappa, there were about 2,500 of these in the collection. And I looked at each and every one of them. And of those, about almost 1,500 came from secure stratified context. So I was able to look at these through time. Now, I did several analyses of these. The first took place almost 22 years ago. And I would look at each and every stone, and I would take detailed recordings of the attributes, the rock type, the color, the texture, the grain size, the patterning of the grain size, any visible inclusions, and the degree of silicification, what might indicate whether or not it was slightly metamorphosed, and the toughness of the stone. Some stones were very sugary and had a sugary texture and were very friable. Others were extremely tough, and they varied highly. And what I found is at Harappa, we had 4 main types. And you can see they're all slightly different. There was one type of a quartzite, one very distinctive spotted light stone, one reddish stone with these very characteristic crisscross patterns, and then stones that were generally whitish to dark gray in color, that they were clearly had been riverborne cobbles at one time. Now, Harappa was located in the middle of the Punjab plain, and when you strip away all the rivers, let me come here, it's the Punjab. And when you take away all the rivers, everything that you see in green there is alluvium. I mean, it is only silt, sand, and clay. There is not a single pebble in that area. To get to a stone, anything bigger than a grain of sand, you have to travel to the margins of the Indus civilization, and this can be quite far. Let's see, click here. The nearest source of stone is 120 kilometers away in the Karana Hills. Then you have to travel west to the Suleiman Range, 220 kilometers. A little bit further to the Salt Range, you can start to get more stone. If you go directly south, you get to the Bikaner area. You get to the Himalayas at about 320 kilometers, and to the outliers of the Aravalli Mountains, about 350 kilometers. There's nothing nearby. So what I did, basically, was travel along the entire margin, observing and collecting samples of the stone with which to compare it to the Harappa materials. Went to the nearest outcrops, and there you found quartzites, and that looked very much like these quartzites from these kind of purplish mottled quartzites from Harappa. This is a grinding stone fragment from Harappa, and this was the closest source of stone. The Suleiman Range, you found this sugary brown stone that matched very well it's a formation they call the Pab. This is Pab sandstone. And the great thing about Pab sandstone, every geologist that I showed in Pakistan these Harappa samples, they immediately knew what it was. This is Pab sandstone. I came to learn that even today they make these all over Pakistan. They make these huge rotary currents. This is still in Pakistan considered the best sandstone for making such grinding stone items. Now, in my travels along the Siwaliks in the front of the Himalayas, I found, particularly in the river basins, you found these water-rounded cobbles, gray, white, other colors, and they were tough, and they make excellent grinding stones. And we find these from Harappa. It took me a while to find this location. I was visiting individual outcrops to the west of New Delhi. But we finally located this area, this one specific set of hills in southern Haryana called the Kalyana Hills. And it's there you find these very distinctive, type of quartzite with this these veiny textures throughout it, sugary veiny textures. And you find these exact grinding stones at Harappa. And they're making grinding stones still like that today, currents, pestles, mortars. And you can almost trace this back to Harappa. Throughout my studies and my travels throughout Haryana, went to early Harappan sites. Mitatal, you see the same stone on the surface. And Siswal, an early Harappan site, you find, again, the same type of stones. You keep going west, even at Kalibangan, this stuff is all over the surface. So I was able to, for Harappa itself, broadly locate and in some cases, in case of the Kalyana Hills, specifically locate the sources of these grinding stones. And so I went back to the collection again and re-examined everything with this knowledge. And I was able to determine that to look at the proportions of these stones in the well-dated Harappan sequence through time, okay? During the early period of Harappa, the pre-urban levels, they were using a stone from the nearest source. They weren't traveling long distance for this. And into the early Harappan phase, they were still using it, although a little bit more Pab sandstone, okay? But you can see that as the phases progress, the local source, which was not the best stone, well, not local source, but the regional source, the Provenance Hills, which was not the best stone for grinding, gave way to better stone, particularly from the Pab range. All right. By period 3C and into the later Harappan period, the Pab range, the Pab sandstone fell off. And during the late Harappan period, from the middle of the urban period through the late Harappan period, you see an increase of stone from the Kalyana Hills, that Delhi quartzite, the most distant source there was, but good stone distinctly becomes greater and greater in assemblage. And this actually, goes well with the findings that the Harappan world at that time, the late Harappan world, was shifting toward the east, toward the eastern Punjab and Gangetic Plain. So now, this type of research where I'm just going and doing observations and I'm not using and collecting samples and not using any particular, high resolution analysis, just looking at the texture, looking at the grain size, I was able to, in the future, looking in other areas, or after this, looking at other areas, I was able to do very similar studies, not just observations, but characterizations. I did a study with Vidya Deja at New York University, and she and a American stone carver were looking at unfinished rock cut temples in Central and South India. And so she had me, she tasked me with going around to these various temples and looking at identifying sources, doing some simple characterizations like X-ray diffraction to make sure what I was looking at. But we looked at temples across this region and look at grain size and inclusions and textures, and we're able to differentiate some very important differences. Looked at soapstone temples in South India, particularly the Hosala soapstone temples, and we compared the mineralogical contents and constituents of these various sources from the quarries surrounding these temples to some of the manufacturing debris found at the site itself, and found some very, very important differences. So I guess my point in showing you all this was it's important to get out there and know the geology, collect representative samples, and know back and forth the materials that you find at the site itself. Because in many cases, simple visual identification and mineralogical and making note of the mineralogical constituents and characteristics of a stone is sufficient to do broad scale geologic provenience studies. Now, switching gears, I'm going to move on to agate. This is very different. Agate is kind of a catch-all term. And when you say agate, basically you're talking about a microcrystalline silicate. And as you can see here, just from this collection from Dolavira, it is visually, it's highly, highly variable. Everyone knows about the red-orange variety of agate, commonly called carnelian. And sometimes ancient peoples would etch these using bleach these using kika leaves and various chemical processes to etch designs into these. But the red-orange type is called carnelian, And when you find these raw, they're in the form of agate nodules, and these are reduced by shaping, perforating, and polishing, and a tremendous amount of man hours goes into making these things, such as the very famous long carnelian beads from Mohenjo-daro. Now, how do you source these? Well, first you have to know a little bit about carnelian itself. Now, this is a simplified version of agate carnelian formation, but basically it goes something like this. You've got gas or water saturated volcanic lavas, and these spread across the landscape, as in like the flood basalts of the Deccan Traps. And as those lavas cool, it's like almost like cooling a bread. They develop voids, vesicles, they're called, as they cool. And over time, as the lava devitrifies, the silica is released. The silica fills these vessels and to form agate. Time continues, and the basaltic rocks, the volcanic parent rock, eventually erodes. And it loosens those agates, and they collect on the surface, or they collect in downriver in a particular formation, and they're loose. And sometimes these they're reconsolidated. Sediments cover them, and those sediments can be iron rich, and it's that the iron in those sediments that imbue certain types with the red color that naturally become carnelian, or they can be heated by craftspeople to bring out the red in them. Now, there are many sources of agate and carnelian across Asia and Eastern Africa. The Red Sea, I won't go into them all, but you can see there are many areas where these could be. But the most extensive formations are in India, and that's because of the aforementioned Deccan Traps. Okay, so I had to travel at many different locations across this region, sampling raw agate. This is a place called Mardak Bet. This is actually in Gujarat it's a small island in the Little Rann, and you can walk across there, and there are pavements of agate nodules. To the south of you, in Ratanpur, in Bharuch, Narmada area, you find these reconsolidated sediments that I was talking about before. These aren't loose on the surface. You have to actually dig down into the sediments to obtain these. But you have fantastic carnelian here. These are imbued with iron. Now, these examples I gave you are in Gujarat itself. And so you have a site like the Indus civilization abutted this to its southeast. And of course, you all know the site of Dolavira, located in prime area to access these resources. So not surprisingly, these are what I'm showing you here are actually examples from Dolavira itself. And so it's not surprising you see the richness and variety at this site like no other. Not Harappa, not Mohenjo-daro, no other. You see these things there, but they were probably, as I'll explain, they were traded there. Now, this is probably the richest source of agate on Earth, and it was known back then as well. The Mesopotamians referred to, we know from the ancient texts, they referred to the Indus civilization as Maluha. And in the text itself, in the Gudea cylinder seals and other texts, they speak of bright red carnelian from Maluha. So we know it was going in that direction. In later periods, in the Periplus of the Erythraean Sea, written during the Greek area, they talk about Bergaza, which is modern day Bharuch, and the Roman intaglios. These are many of these we're presuming are coming from the Indian sources. During even later, during the Islamic period, the site of Kambat was well known for producing so much of the akik that is so highly valued in the Islamic world. Now, even later. I mean, there are other regions and other connections in later historic periods where, particularly as Buddhism, Hinduism spread to the east and southeast, that likely there were trade routes through which this type of agate could move. Now, but yeah, so India was this prime source. But as I mentioned before, there were potential other sources. How do we know it all came? Can't necessarily assume everything came from India. So, for the past 20 years, and we've done more of this really in the last 5 or 6, Professor Canoyer and I, this is not my project alone, and others have collected samples not only from India, but from agate and carnelian sources ranging from Eastern Africa and Egypt, Sudan, Turkey, across Arabia, into Southeast Asia, Japan, Mongolia, China, Iran. We've managed to, if not personally collect the samples, work with geologists working in these, doing research in these areas, and finding locals who would, particularly places like Iran, which we can't presently get to at the point, get stone for us, get samples for us. And so to date, over 600 geologic samples representing nearly 40 individual agate deposits from Egypt through India to China have been analyzed to date. We analyze these using a technique called laser ablation inductively coupled mass spectrometry. And in a nutshell, it's like this. You have a mass spectrometer coupled to a laser unit. You place you place your sample, your bead or raw material, and it pulsates in an argon-filled chamber. It pulsates the laser at different points along the stone, and the pits that it makes, that it vaporizes, are I cannot honestly say it's non-destructive. It is. You're vaporizing little pits out of the laser, but with a laser, but these are barely visible to the naked eye. So the vaporized material is carried to via argon gas to the ICP-MS and analyzed, and you can get good quantitative data for 52 elements. And these change from place to place, given the geological formation in which the agate formed. As I said, most of these formed out of volcanic lavas. They were originated in volcanic formations, and these vary from place to place. So with all this data, you can evaluate it I use canonical discriminant analysis. We use, to a lesser degree, principal component analysis. And we're able to match these we've had great success matching these to their sources. It gets a little tricky, for example, looking at a place like the Deccan Traps of India, where you're looking at a volcanic formation, which is largely homogeneous, not completely homogeneous. There are different layers. It took place at different times, but it can get tricky, but it's possible. Now, again, all this costs a bunch of money. Again, such a large, extensive study. I have to thank a lot of institutions again. I showed this before, but these are the samples analyzed to date. We've not only analyzed these samples, but these in black here are the archaeological sites for which we've analyzed agate and carnelian artifacts from all the way from Africa to Mongolia and Southeast Asia, and not across China as well, or India as well. Now, I'll quickly go through some of these results. I can give you we're in the process of publishing a lot of this stuff, but as you might expect, the agate carnelian that you find in the Harappan world is almost entirely from sources in Gujarat, as you may well expect. But at places like Harappa and Nalshara, there are indications that some of this could be coming from the west, from Iran. The agate carnelian beads that we're finding in Oman, some of these are clearly made by Indus craftsmen. Some of them are local. We find there is input both from India and Iran. The long carnelian beads from Puabi's burial in Kish. Some of these are in the Field Museum here in Chicago, or near Chicago, and we were able to confirm that these are actually from the, excuse me, back there. These are actually from, as you might expect, India. This is not my work. We have one of Mark Knorr's students, Dr. Jeffrey Ludwig, actually was able to identify Harappan beads and later period sites. These are Harappan beads and post-Harappan period sites in the Eastern Mediterranean, like Troy. Now, these beads, we're able to confirm these were Indus beads, but they were obviously being, particularly the long carnelian ones, where you see fragments of, were being curated and passed down. But we confirmed that they were Indus beads. Okay. Another Professor Knorr's students, Dr. Alison Carter, was able to identify Indus beads in Southeast Asia. And another colleague of ours, Dr. Jennifer Craig from McGill University, was able to find these during the medieval period, during the colonial period, in a Spanish galleon wreck off of the Philippines. So, and recently, just last year, we published a study of carnelian beads in Mongolia. Now, that's a long way from India. And not surprisingly, we found that most of the raw carnelian that was being used by Neolithic and medieval period peoples, who looked at multiple sites, medieval period peoples and Neolithic peoples in Mongolia, was actually local stone. No surprise there at all. But we did find some interesting outliers that appeared from the medieval period that appeared to come from Yemen. And we also had found previously beads like that before from collections from Afghanistan. So it was a good possibility that during these later periods in Mongolia, there is this evidence of this long distance overland trade. So India is clearly a major important source. And we're still looking at these other areas in the future, and this is a long ongoing study. But I think we will continue to find that Indian carnelian, particularly as these trade routes developed first in the Harappan period and through the early historic, medieval, Islamic, and historic modern era, it's still a major source of carnelian, just as it is today. This is an agate bead maker. I showed you this before in Kambat. All right, I'll finish this talk off with a discussion of some of the metal sourcing studies that I've been doing. And again, I won't go into any great details each individual one, but I'm happy to answer any questions regarding any aspect of this as we go. Now, I have not yet got to study gold. This is on my to-do list, but I have done extensive work. We have done extensive work on copper, silver, and lead. So both common metals and precious metals. One of the most powerful ways with which to match the metal artifacts to their potential raw material sources is through the use of lead isotope analysis. Lead has 4 stable isotopes, 208, 207, 206, and 204. And if you're using ore from a single source, the ratios of these isotopes do not change from the ore through purification, through hammering, and making into the finished object. Provided that you don't mix it with ore or material from another source, a different metal from another source, the isotopic ratio should remain the same, and you'll be able to match. Okay. Now, surrounding the Indus Basin, this is a slightly old map. I have a few more sources in this. I was able to get either already in the geologic data A lot of the geologic literature already had the analysis of the lead isotopes done for the geologic formations due to this is an important way for geologists to date the ages of certain rocks and certain mineralization events. So a lot of the work was done for me already, and where it wasn't, I was able to collect samples and do the analysis myself. Now, when you plot the ratios of the different lead 208 to 207, 207, 206, it forms these curvilinear formations. And when you place the superimpose the artifacts themselves onto certain onto the map of these sources, you're able, with a high degree of confidence, to say that these particular artifacts are coming from these particular regions. Now, until probably about 10 or 15 years ago, the go-to way to actually sample artifacts was to cut a piece of the metal from the artifact. So it was a destructive process. You actually had to take a chunk of the metal off, dissolve it, and do the analysis that way. But about 15 years ago, with a colleague of mine here at the University of Wisconsin named Jim Burton, developed a way to sample non-destructively lead from metal artifacts for analysis. And what we used was purified water with a small amount of a chemical called EDTA, ethylene diamine tetraacetic acid. And basically what that does, it's a non-toxic chemical, which you find in salad dressing, shampoo, some toothpaste, but it forms one-to-one coordinate bonds with heavy metals such as lead. So if it comes in contact with lead, it'll bond to it. So we put a tiny amount of that in purified water, and we take that purified water to the archaeological site or to the museum, and we take an artifact like this inscribed lead piece from Harappa. We place that artifact into a polyethylene tray, and onto that we pour the purified water with a tiny 0.05% amount of this chelating agent called EDTA. And for a minute or so, we let the artifact sit in there, and then we pour the water back into the vial, and we dry it. We rinse the artifact in purified water, let it dry, and we don't have to take the artifact back to the lab. It can go back to its place of storage in the museum or the archaeological site. It never has to leave the country. And we take the vial of water back for analysis because now it's been enriched with lead from the artifact. Now, this is a great way to do this because it is, for all practical purposes, non-destructive. It's easy to do, it's fast, it's inexpensive, and you can sample, as I said, at the site itself. You don't have to apply for export permits to bring samples from India to the United States, which is, for very good reasons, not easy to do and sometimes problematic. So you analyze the water on the lead-enriched water on a multi-collector ICP mass spectrometer. Now, I've done this for in between 2013 and 2015. I was in India sampling hundreds of sites. I've taken thousands of samples, and so I haven't analyzed everything yet. This is one of those things that's still in process, but we analyzed copper from Dolavira, including this large copper. We're not exactly sure what this is. It's maybe it's a large copper rod, but we've analyzed copper rods, the raw material found in Harappa itself, Dolavira itself, copper ingot fragments, a bowl, spear tips, and also other materials from other sites in Gujarat, Kanmir, Agate, Shikarpur, and importantly, sites not in Gujarat, but sites not of the Indus civilization, but cultures contemporaneous to them in southeastern Rajasthan, like Balaton and Gilland. And what we found was that when we plot the results, right, we get a picture of the trade of copper and lead in Gujarat that is actually highly, highly complex. And some of these, like the Ambaji source, this is a well-known, it's still a source for copper, silver, and other precious metals today. But the Gujarat Mineral Development Agency has a big mine there, open pit mine. I'm not sure if it's still active, but it was until very recently. Um, there have been studies, they're going on 30, almost 40 years now, of the ancient mines there. It's very rare to find these ancient mines because a lot of them are obliterated by new mining activities. But the ancient mines there, by looking at some of the associated artifacts, were able to estimate the date of usage to the early historic period based on what they found there. But with this study, we're able to show that it was being well exploited during the Harappan phase, almost 2,000 years earlier. So it's through these types of studies that we're able to actually push the dates of exploitation back there. And the same is true of Zawar. We have one copper artifact from Gillen that precisely matches the isotopic characteristics of Zawar. And so again, this is the earliest evidence that material from that site, from that raw material resource, was being used. So we did a little bit of work in Oman as well, more recently, looking at silver artifacts. A number of silver artifacts found in a burial. Interestingly, we found these match precisely, not with the Indus, but with silver sources, well-known silver sources in Anatolia, and likely came through sites like Ur, Kish, Assur, sites in central Mesopotamia during the Akkadian period, from which there were also found silver artifacts that matched those Anatolian sources. So this was actually kind of unexpected. At this particular site of Dawa, they had found Indus beads. So I was thinking that possibly, when we first began the study, that possibly that this might have been Indus silver, since it was found in general association with these Indus beads, but no, it was Anatolian. So this area, which in ancient times was referred to as Magan, was a real crossroads, a melting pot of these influences from both the East and the West. Now, I'll just show you this. What I have going on right now, we have actually got to analyze some materials from Taxila. Well, we're in the process of analyzing materials first excavated by Sir John Marshall and others from the site of Taxila, currently in northern Pakistan, and silver vessels. We were able to analyze, and things like punch mark coins. We're able to analyze these specifically because of this non-destructive technique. You wouldn't want to even cut a small amount of these rare and highly valuable artifacts like these silver coins. But using this EDTA method, we're actually able to do that. We fill these with water. You submerge them with the EDTA solution. You submerge it for a short time. The solutions go back in these vials, and the EDTA goes back to analysis here in the US. Now, the results of this, unfortunately, have to be continued. I just got these back. I don't have any plots prepared for these, and actually we're still considering a lot of these, but given its region and the coins, we're finding a lot of different silver from many different possible sources, some a great distance away. So that, I believe, I'm probably out of time. So that is really where I'm going to have to end. As I said, I could and happily have before talk about aspects of this all day. So if anybody has any questions, I'd love to hear them now. And if I didn't explain anything or I went over something too fast, please let me know, and I'll try to clarify anything. Thank you.